So imagine you have a database in which you can insert the data, and at the same time you want to know if a particular data is present in that database or not. So for example, if you will consider a database of names where only names will be put, so at some point of time, if you want to know if a particular name, let's say called Sachin, is present in that database or not, so this is one of the operation that you want to do. So one thing that you can do is you can just scan the entire database using some queries, but it is not efficient. Using queries on database is slow, so we do not want that. So we want it to be better than this. So the other option is using hash tables. So what we can do is, while inserting the data into database, so before inserting the data into the database, we can put the data into the hash table, and we can just mark that data as present in the hash table, and after that we will put the data into database. Now, when we will want to know if the data is present in the database or not, we can just go to the hash table, and in constant time we will come to know that if the data is present in the database or not. But using this approach as well, there is a problem. So as the size of data will increase rapidly, the size of hash table will also grow at the same rate, because the number of the data that we are putting in the database, same data will also be kept in the hash table, so the size will also increase rapidly. So we are also in the space constraint. We want this query to be faster, but at the same time we do not want to use a lot of space. So, to solve this problem of space, we will use Bloom filter. So, as the name suggests, it is some kind of filter which is developed by a scientist called Bloom. So, Bloom filter. But it is actually a data structure which will tell two things. It will tell if the element is not present in the database. If it will say element is not present in the database, that means 100% the element is not present in the database, and there is no chance that element will be present in the database. But it cannot tell us if the element is surely present in the database. It can just tell element may be present in the database. This is a compromise. It will not surely tell that if the element is present in the database. It will only tell element may be present in the database. So again, I'm telling this is a compromise that we are doing to save the space. If there is no space constraint, we can go for some better approaches which will surely tell, which is not probabilistic in nature. This is probabilistic in nature, because it will not surely tell if the element is present in the database. It will just tell it may be present. So if we have to define it, it is a space efficient probabilistic data structure which tells if the element may be present in the set, or it is not present in the set. It is false positive, but it uh, is not false negative. So as you can see in the diagram, Bloom filter is basically an array of size m, and it can have values 0 and 1. So it is used to tell if the element may be present in the database or set, or element is not present in the set. It is used to tell that. So I will try to explain the working of Bloom filter, and I will not try to overcomplicate things. So I will take the example to make you understand the concept of Bloom filter. So imagine a situation. uh, so imagine you have a database which is used for storing names, and we have a data called Sachin, and we want to put this data into the database. Now what we were doing earlier was we were storing this data in hash table. uh, so we were representing this data into the hash table, but now we have to represent this data into the Bloom filter. So how we will do this? We will pass this data Sachin, which is a string, to a hash function, and hash function will generate some numbers for this uh, data, for this name. So think of hash function like a box which will take this name and generate a, let's say, integer. And this integer can, let's say, be very huge. So we do not want it to be huge because the size of index is only m. So we want it to be from 0 to m minus 1. So we will whatever the value we will get from that hash function, we will mod it with m, and we will get the resulting answer from 0 to m minus 1. So whatever value we will get, let's say in case of Sachin we get 5, so we will set the fifth bit. So setting the bit means from we will change the value of fifth bit from 0 to 1. And this is how we represent that Sachin is present in the database, and we will put the data into the database. Now when we want to check if Sachin is present in database or not, we will again pass the uh, Sachin in the hash function. Hash function will generate some integers, some numbers. The numbers when mod with m will again give 5, and since 5 is set, we will tell that uh, Sachin is present. But now we have a problem here. The problem is, let's say there is a name called Virat. We pass this name Virat into a hash function, and that generates integer, and when we mod it with m, we again got integer 5, and we again set it integer 5. So this is the problem, right? So this is why when an integer is set, we cannot surely tell if it was Virat. We are still in confusion if Virat set the bit or if Sachin set the bit. So we cannot surely tell if it was Sachin who set the bit and is present in the database, or if it was Virat who set the bit and is present into the database. So this is a problem, but we can improve this problem to some degree. We cannot make it perfect, but we can improve this problem to some degree. So to improve this, we will use multiple hash functions instead of one. So instead of passing this name Sachin from one hash function, we will pass it with multiple hash functions. So in the diagram you can see we are passing through three hash functions. So we can pass through k hash functions any number, but the more the number the better it will be. But uh, in this case we will be passing through three hash functions. So the name Sachin is passed to three hash functions. Three different integers will be there. We will mod it with m. We will get three different integers from 0 to m. And let's say for a name Sachin, we will get integer 4, 5, and 9. And now to represent Sachin, we will set integer 4, the index 4, the index 5, and the index 9. By setting, we means I mean converting the 0 to 1. So uh, these now the 3 bits is used to represent Sachin. So now chances are less that there will be another data that will be used to represent with the same set of indices. The chances are less, but still there is a chance, and that is why we are saying this is a probabilistic data structure. So when uh, let us try to understand what happens when we search. Now when we want to search if Sachin is present to the database or not. Now since five in this case there were three hash functions, we got three indices, and three indices were used to represent Sachin. We will, let's say in this case it was 4, 5, and 9. So now while searching we will go to 4, 5, and 9. If all the three bits are set, that means Sachin may be presented into the database, because there is still a chance, although we have reduced the chance by using multiple hash functions, but still there is a chance that there can be some another data that is used that is represented into the Bloom filter with same set of indices, but still there is a chance. So we cannot surely say, but we can just say it may be present. But if out of the key bits, out of the 3 bits in this case, any bit is unset, we can surely say that Sachin is not present into the database, because uh, the bits that were used to represent Sachin are not all on. That means not only Sachin, but there were no database which were represented using these 3 bits. So we can surely say that Sachin is not present into the database. In the next video, I will be implementing Bloom filter in JavaScript. I'm not saying it will be the best Bloom filter implementation, but I will still suggest you to watch it, because after watching that, you will have a better understanding about the Bloom filter. This I can guarantee. So must check it out.